Now let's introduce you to the Vscpr theory. Now the Vscpr theory stands for valence shell, electron, pair, repulsion theory. Okay, this is what the Vscpr stands for. There are three main rules, okay, but for now you only need to know two, and it's very basic. The first important one that you need to know is this, which is that the electron pairs tend to rearrange themselves in such a manner to minimize electron repulsion. In other words, they want to be as far apart from each other as possible in order to minimize electronic repulsion. Now, the second theory is that the lone pair will exhibit a greater repulsion than bond pairs. So what does this mean for us? Okay, so for example, if you have three electron regions, they will be oriented this way in three regions of space around your central atom. Okay, so this is how it will look like. This would be the best way to arrange them such that they are as far apart from each other as possible. And the bond angle for this will be 120 degrees. Okay, imagine now if you replace one of the bond pairs with a lone pair, this will be how it looks like. For purposes of considering the shape, you only consider the bond pair. So therefore, we call this a band shape. Because of the lone pair repulsion, okay, the lone pair will repel and push the bond pairs closer together. So therefore, the bond angle for this will be less than 120 degrees. Now let's come to the 4 electron regions. Some students mistakenly think that the best way to arrange 4 electron regions would be as a square. But this is wrong. You will notice that the maximum electron angle, the maximum bond angle over here will just be 90 degrees. But there is a way to rearrange them such that the electron pairs are even further apart. Okay, because if you arrange them as a square, you are just considering it in 2-dimensional space. Okay, but there is actually a 3-dimensional space. Okay, so if you look at this, this is something called a tetrahedral. Okay, it's something called a tetrahedral. It allows your bond pairs to be more than 90 degrees. Now, how do we visualize this? If you look at the white color balls, okay, let me just pause the recording for a while. Let me pause the screen share for a while so that you can see this clearer. Okay, so if you look at this, can you see that the white color balls are on the plane? Okay, which is my hand, it's on the plane. Whereas the green color ball is coming out towards you, the yellow ball is going in away from you. Now, how do we represent this in the drawing? So this is how you draw for 4 electron regions for 4 bond pairs. Okay, the white color balls, as what you see on the screen, they are in the plane, so therefore we represent them with single lines. Single lines means they are in the plane. Can you see these two? They are in the plane. The green one is coming out towards you, so we represent that with a bold line. The yellow one is going away from you. And if you look at this, the yellow ball is going into the paper away from you, so we will represent that with dashed lines. The angle for this is 109 degrees. Now, if you remove one of them, they are completely symmetrical, so you can remove any one. So when you remove one of them, this will be how it looks like. So just now that one was called a tetrahedral. Now the one over here looks like a triangular pyramid. Can you see? It looks like a triangular pyramid. So therefore we call it a trigonal pyramidal. And this is how we draw it. Okay, this is how we draw it. Okay, just remove the top one and replace it with a lone pair. So this is how it looks like. Let me reorientate it. This is how it looks like. It's a triangular pyramid. The angle, because of the lone pair here, it will push the bonds closer together. And the bonds here will be pushed closer together. So therefore, the angle here will be 107 degrees. Actually, the tetrahedral 109.5. Okay, so you'll be closer together. Okay, now if you remove one more, now you can see that it goes back to the bend shape. Right now, it goes back to the bend shape. Okay, it goes back to the bend shape, and it's planar. You can lie flat on the plane. You can lie flat on the plane. Okay, so how do we represent it? With just single lines. So this is 104.5 degrees, because now you have two lone pairs which will push the bond pairs even closer together. Okay, so this is a brief introduction to VSEPR theory. This is 1 minute of chemistry. I'll see you the next time.